Hello, everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar will be talking about templates and modified geometry. And the reason actually why we actually picked this particular subject is even though we've had templates already for quite a while, and we've also been using already modified geometries, we've noticed that there are a lot of customers out there, a lot of people that are not using them enough or not taking full advantage of what we actually have to offer over there. So I'd like to actually do a webinar again, showing you these options and also comparing them into ways you would have to work if you didn't have those options available to you. As usual, you always have a chance at the end to ask questions. If you have any questions, all you have to do is simply click on the button where it says raise hand, and in the question area, just write down the question, and don't forget when you finish writing down the question to click on the send button so that I can actually see the questions at the end, and I will try to go over all the questions at the very end to answer them to the best of my abilities. Okay, so let's get started with the webinar itself. And what I'd like to do is first start off with the issue of templates. Now, what exactly is a template, and what are we actually trying to get out when we out of templates when we actually create a template? Well, a template is an operation that you can actually save to use all the parameters that you have in a specific in a specific operation, and you want to use those specific parameters in different operations as well. Not only in this project that you have, but in different projects as well. For example, we'll take a very simple case where you have a face milling operation. Okay, and I'm actually going to open up the face milling operation that I have over here, that I've done on this particular part. Now let's take a look before I even open up the operation. I'd like to clear off the very top of this face over here. Now, in this particular case, the width of this part of the actual stock over here is 104 millimeters. And the type of face mill that I have is 125 millimeters in diameter. So if I were to take a look at the top view, I can actually take a tool and go directly over the center of the part itself with one pass to clear off all of that material over there. Now this is an operation, for example, that many people repeat over and over and over again on different parts. And it's like almost a ABC of way many people will start working in many cases. So let me actually open up the operation and we'll see exactly what we're going to do. If I were to open up the first operation that I have over here in this part, this is a face mill operation, and the tool that I have is, as I said, 125 millimeters, and you'll note also in the levels I've set my safety distance at 0.5. I've decided this is the way I want to work, for example, and I want to have a safety distance of 0.5 because I'm actually going from the outside of the part, so I have no fear of actually going down on the part itself. So I left a safety distance of 0.5. Again, this is my own preference. Anyone can work with the way I want, but the idea is to show you that I'm setting up a specific preference. Now, also note, in my technology, I'm using the option of one pass. Okay? Now, this is an operation I would like to do in many other parts. So I'd like to save all of this in what we call a template. This way I can use this on different parts as well. So when I go to save it as a template, this is done very simply by on top over here. We have the option within, and this is, by the way, available in every single one of our operations in SolidCAM, whether it be profile operations, face operations, in 3D operations, 5-axis simultaneous operations, turning operations, mill turn, every single option that we have inside SolidCAM has this option of template at the very top right hand corner. Okay, I like to create the template. So to create it, we have the option of save template. When I save the template, it's actually saving everything that I have inside that operation except for the geometry. Now, I'll give it a name. For example, I'll call it face FM for face mill, one pass. The name really doesn't make a difference. It just, as long as you understand what that name means. And I'm give it also an add 125D, telling me that I'm using 125 millimeter diameter. Okay, now one more thing should be noted, that at the very bottom we also have an option called include tool data. This will actually take the tool data that I have inside the operation and include that as well inside the template that I'm creating. I'm going to say OK, click on OK, and note I have other templates here as well. I'm just going to click on OK, and my template is set. Okay, now I'm going to actually close this part now, and I'm going to open up a different part, because I want to create now a different template as well. I'm going to create another template from this part itself, as we will see in a moment. Now this particular part, this is I also want to do a face mill here, but in this particular case, this is a wide face on top. It's 154 millimeters, and I don't want to do this in one pass. So I'm going to create another template. Again, I'll go into the operation that I have over here. I've used in this particular case a 100 millimeter diameter tool. My levels, I like working the safety distance over here, as shown over here. And my technology, I'm working hatch, using the hatch operation. And in the hatch operation, I've also opened up the option of corner by fillet. Just taking a quick look at the simulation of this, you'll see that this is the exact tool path that I want, and that's what I received. Okay, now I'd like to save this as well as a template. Again, I can save another template, save template. I'll call this FM hatch and 100D. Okay, again, include tool data. And I'll click on OK. Okay, fine. Okay, tomorrow I'm coming back to work, and I have a new project that I have to work on, and I want to use these templates to make my day easier. Now, how do you use the templates itself? Well, there's several ways. One of the ways, let's say for example, I'd like to have my face mill, whenever I open up a new operation, to open up a new face mill operation, I want it to open up with that template already there. For example, let's say that one pass operation that I did is something I do almost all the time. So I want to save that in a way that it'll open up every single time I choose a face operation. So the way I'll do that is simple. If I go into SolidCAM and I go into SolidCAM settings, we have the option of default templates. And note, I have a default template face over here. You notice I have 2.5D milling, all the different types of modules over here. And in my 2.5D module, I have all the different operations. I'm choosing face. Now, if I open up the list over here, I want to choose one pass 125. That's the template I want to have open automatically when I open up a new face operation. I'll click on OK. And now I'm going to open up a new part. I'm going to open up a new part over here in SolidWorks, a part that looks like this. And I'm going to start my new project, milling. I'll create that, no problem over there at all. Just choose my coordinate system. I'll click on the face. It's in the center of the part. And in my case, I have my settings set so that it creates the stock and target automatically. And now we're set to go. Now I'm going to start my face operation. So I'll go into my 2.5D face. You'll note that it automatically loads with that particular template. Now, apparently I chose the wrong template that I wanted to have over there. I wanted to have 125 millimeter over there instead. No problem. First of all, I can always go and load a different template if I want. Okay? Also, by the way, in my settings over here, if I were to go into settings, I can say for this particular part, I want to have a different default. Say that one, for example, one pass. I'll click on OK. And I'll start my operation. 2.5D face. And you see I have my one pass over there. Okay. All I have, you'll note, in this particular case, my tool is already here. If I go into my levels, you'll note that I have my safety distance already set. All I have to do is deal with my upper level and lower level. I'm just going to leave this at, I'm going to have my upper level at 0.5 as well. Just leave it the way it is, my down step. My geometry, of course, that's one thing I still have to create. And I'll use the target over here as my geometry, and I'm set. I don't have to go into technologies. You can see my one pass is already over there. Save and calculate, and we're done. You can see the tool goes down and clears the top of the part. Okay? And note, I didn't have to create a tool. I didn't have to make my changes in the parameters over here of safety distance. That's the way I wanted. My technology was already set. Everything was set exactly the way I wanted it to. Okay, now I'm going to open another part very similar to the part that I had just now. And I'm going to actually start differently. This time I'm going to start new milling. I actually started the same way I did it before. Create my home position. And we'll accept that. And as I said, my stock and target are already defined. And I'm all set. Now this time when I go into my 2.5D milling face, you'll note this time it has the hatch parameter, template here as my default. Okay. Tool, my geometry, you can see my tool is already there, the 100 millimeter tool. All I need to do is create my geometry, and I'll do that over here. And we're basically all set, exactly. I don't have to do anything else. Save and calculate, simulate, and as you can see, the tool goes down, including the fillet that I had, the fillet connection between the tool passes over there. Okay, now I'm going to continue with templates in a moment, but before I do that, I'd actually like to start talking about the option of modify. Now, we have an option in our profile, also in Pocket as well, and in Drill. We have something called modify geometry. Now, let me take a look at this area over here. This area over here, this entire floor over here, I'd like to actually mill out. And the way I'd like to mill this out is to first have an operation where the tool pass goes down the exact middle of this. Okay? And maybe even in a helical fashion going around. And after that, I have another operation of clearing off the walls. Okay, now the distance between this wall and this wall over here is a total of 10 millimeters. Okay, now in order for me, without using the option, if I didn't have the option of modify geometry, In order to go down the middle, I would have to create a sketch. Okay, so let me create a sketch here. I'll choose that as my surface where I want to create my sketch. And I'll say, okay, you know what? Let's grab this line over here, right click on it, and I'll take the tangency of that. And I'll say, okay, let's do what we call, just put it on my top view. We don't need to at that moment. I'm just going to do offset entities. You'll note that my entities are being offset. I'm just going to do reverse. And I want to do half the distance, which is a total of 5 millimeters, because the total that I measured before was 10 millimeters. Okay, that's my chain that I created. Okay, in other words, in order for me to do that operation, I have to create a chain to go around. And to do that, I created a sketch. Okay, so now let's start the operation. I'll go into my 2.5D. I'll go into Profile. And I'll choose New. Click on that line over there. Auto Constant Z. And I have my geometry. But note, I had to create a sketch in order to do that. Okay, continue. Now this was, I'm talking about if I did not have modify. And I'll show you modify obviously in a couple of moments. My tool in this particular case, I'm going to be using an 8 millimeter end mill. So I'll add a new end mill over here of 8 millimeters as shown over here. Okay, and I'll accept that tool. My levels, my upper level is going to be over here, and my depth is going to be down over there. In my technology, I'm just going to tell it to work, not on the left side, but on the center of the toolpath. And instead of constant, I'm going to use the option of helical and step down every 3 millimeters. In other words, every time it goes around, it'll go down 3 millimeters as it's cutting down on the part itself. Let's do a quick save and calculate and run my simulation. You'll see that the tool goes down, works exactly in the middle of the part as shown over here. Let me actually turn it so you can see it a little better. Get this out of the way. And as you can see, the tool is going down, cutting exactly in the middle of the part as shown over here. Okay, now note, this is exactly what I want to do. But in order to do this, I had to create that sketch again. Now, my next operation, I'm just going to do save and copy just to keep some of the parameters. And I have to now create a new geometry in order to finish off the walls. So I'm going to create now a new geometry. And I'll click on this edge over there, grab that chain, and I'm going to click on this edge over there and grab that chain as well. Okay. My levels, my depth will be up until that floor over there. This time my technology, I'm not working center, I'm working left. And I'm going to also be working our regular constant option over here. Let's have my step down at every 5 millimeters. And I'm going to go into links, change my lead in to arc, same as lead in. And my radius I'm going to use, let's say I have a width of 10 millimeters and I have an 8 millimeter end mill, leaving one side of material on the side. So I'm just going to do this with a 1 millimeter radius. Okay. Save and calculate, run my simulation, and you can see that the tool is going down exactly the way I wanted it to, but I had to create another operation, another sketch to do this, and creating a new geometry in order to do that. Now, one more thing I can also do, I have to do the same thing with these slots as well. Again, I would have to create a sketch in the middle and then off to the sides to finish that off. Let's see how I can do this by using modify geometry instead. I'm going to take these two operations that I've done over here. I'm going to suppress them as if they were not done at all. And I'm going to create a new, oh, didn't do that, my mistake. That and that. Right click, suppress. There we go. Now they're suppressed. Now I'd like to create another operation again, but this time I'm not going to use this sketch that I've created over here. Instead, I'm going to use the option. I'm going to use the geometry that I've created for the very bottom of two sides, but use modify geometry to help me out instead of creating another, having to create a sketch. I'll even take the sketch that I have over here and I'll even hide it so we don't see it. Okay, so I'll start again, 2.5D operation, profile. I'm going to use that second geometry as shown over there. The tool that I'm going to use is going to be the end mill as I've created over there. Levels up until that surface over there. And in my technology, I am now going to use the option of modify geometry. We'll put this at the top view and we'll go into modify geometry. First of all, you can see that we have our two chains. Well, I only want to work with one of them at this point. So at this point, I can say, you know what? Let's only work with chain 1. Okay. Now I'd like to have the tool be on the center of chain 1. So I'm going to say, okay, we're moving to the center. You can see that is done over there. Next, I'd like to take this chain and actually move it to the middle over here, in between those two geometries, those two chains. So I'm going to click on chain 1, and I'm going to say, you know what? Let's do a modify geometry, taking half the distance, and I'll go now to the second chain over here. And as you can see, it automatically jumps to the middle, half distance. I'll accept that. Now I'm finished with my modify over there. I'll do helical ramp in, step down every 3 millimeters, and that's it. Save and calculate. Let's just run my simulation quickly, and you'll see it does exactly what I wanted it to do. It'll go down the middle. Exactly the way I wanted it to work. Now all I have to do is save and copy. I'm not going to change the geometry. I'm keeping the exact same geometry. Go into my technology field and just make a couple of changes over here. First of all, I'm going to change my geometry field, have it go left instead of only on the center. I'm going to use this time both chains, not just one chain, but both chains. And I'm going to set my offset back to 0 and apply to all chains, as shown over here. Now you can see it's working exactly the way I wanted to, without making new geometries. In my link, I'm going to just have this one goes in arc, radius of 1, same as my lead in, save and calculate, run my simulation, doing exactly what it's supposed to do. As you can see on the part itself. Okay, now this is done by using one geometry and just modifying it. Now, one more thing I'd like to do is I'd like to also work on these slots over here. Now, if I'm looking at it actually, these slots are very similar to the operations that I did over here. I'd like to go down the middle and then clear off the walls. But you know what, so what I can do is take these two operations that I've done over here, and I'm going to actually create what we call a group template, where it actually takes the entire group that I just chosen over here and makes a template out of them, keeping all the parameters that I have inside the operation. So right click here, and we have the option called Create Template. And this is creating template from this group. And I'm going to call this center, center and sides. And I'm going to write 8 DIA, and that's and include tool data. Okay. Now, how am I going to use this? Very simple. Going to over here, we have what we call from process template. This is actual process. When I click on that, you'll note that I have all the different templates that I have, process templates over here. And as I said, I'm using the new one I just created, center and sides 8mm diameter. Okay? I'll accept that. And let's just create my geometry. In my geometry, I can create it right here. Since both of them are using the exact same geometry, I'm going to define, and I'm going to click 1, accept that, 2, accept that, 3, 4, 5, 6, 1, and one more set is this set over here. And that's my chains that I need. Okay. I can do upper level and lower level here if I want. I'm just going to leave it the way it is right now. I can do that in the operation as well. Now, when I do that, now let's go into the operations. Now, you'll note I have my geometry over here. My tool is automatically here as well. And in my technology, my level, I'm just going to set my levels. My upper level and my depth over here as well. In my technology, you'll note I already have center. But since we have new chains over here, I have to tell it which chains I want it to work on and which chains I don't want it to work on. So if I go into modify geometry, I can say, okay, number 2, 4, 6, and 8 are the geometries I don't want to work on. In addition, I wanted to work with a specific offset. What's the offset? Again, take half. If I go to 1 over here, I'll just click on this side over here, and it moved it half the distance. In addition to that, I'm going to click on Apply to All. So it does this for all of the chains here as well. You know what? There's one more thing I'd like to do. I'd like to also have this extended pass. Now, just because I made a template doesn't mean I'm locked to it. I can make any changes I want if I want to, because templates, it just gives it as a default, but I can always change default values. So I'm going to have an extension over here, so it goes out further. I would say 4.5 millimeters. Same thing for my end, 4.5 millimeters. And since I want it on all of the chains, I'm going to click on Apply to All Chains. Note, all of them have been changed. All I have to do now, save and calculate. Now let's run a quick simulation over here. And as you can see, every single one of those steps were cleared out exactly the way it should have been. Now, if I were to go into the next operation, you'll note in this operation, we have our geometries. We have our levels. Let me just set my tool is at 8mm end mill. My profile depth is up until that surface over there. And in my technologies already we have the left. Okay. In modified geometry, you'll note I don't have to change any chains over here because this is exactly what I want. The only thing I'm going to add over here is just the extension. So I'll add an extension over here, 4.5, over here as well, and I'll say apply to all chains. Okay, note my offset is set at 0. One more thing I like to do, in my link, I'm going to have this as none, as far as my lead in and lead out. Again, even though I chose the template, doesn't mean I can't make changes in it. Save and calculate, simulate. and you can see it finished off those rules. Let's do this actually one step at a time, and you can see it actually over here. The tool goes down and then works on the other side as well. Okay, now the advantage, as you saw over here, is I did not have to create other operations. Everything was inside my template itself. So I didn't have to go back, choose a tool, choose the type of technology. I just made some minor changes that I needed, and everything was right there. Okay, now one more option I'd like to show you inside Modify Geometry is we have an option. If I were to open up just for a moment this operation that I have over here, let me go into my technology, and we have our geometry. We have our extension over here, but I can also use a negative extension. Now let's see exactly how negative extension can be used. I'm going to use an operation to clear off the chamfer on these edges over there. Not a problem. 2.5D, profile. Let's actually put this on the top view to make it a little easier for us, and I'll create my geometry. 1, 2, 3, 4, this one over here, this one over here, this one over here, as well as this one over here. Okay, and we're all set. We have our geometries, everything's set down here, no problem. Exactly the way I want it. Okay, I'll choose my tool. My tool in this particular case is going to be a chamfer mill. So I'm going to choose the option of the tool of chamfer mill. I'm going to have it at 6 millimeters. I'll select that tool. My levels, my profile depth will be the depth of the chamfer I want, say 0.3 millimeters. And in my technology, I'm going to use the option over here of chamfer. Now when I use chamfer, we have our cutting diameter over here. I can use any cutting. Now the tool itself is 6 millimeters, but I'm not going to use the 6 millimeters as my cutting diameter for this part. I'm just going to use right now the cutting diameter of 2 millimeters over here. In other words, the part that actually cutting the edge of the geometry is going to be of the diameter of 2 millimeters. Now, one more note before I continue is I'd just like to mention something about compensation. When using the option of chamfer, I highly recommend not to use compensation. Okay? The reason why you shouldn't use compensation is many times you may be using this exact same chamfer tool, but in certain cases you may want to use a different diameter. If you're using the option of compensation, this can be a little bit of a problem. If you need to make a change as far as the depth of the cut, in other words, you have a chamfer too big or too small, what I suggest is always just changing, doing the adjustment on the machine as far as the depth of the tool itself. If you change the depth on the machine, it'll actually, and you get to the right chamfer that you want, that will actually then work on any part that you have using that tool. Okay, so we have the option of compensation. I got rid of that, and I'm using the option of chamfer. And in my link, I'm just going to have a normal approach of, let's say, 3 millimeters, lead in and lead out as well. Okay, let's run my simulation. Let's see what we're actually going to what's going to happen over here. I'm going to use the option of solid verify so we can see what's going on over here. And you'll see that the tool will go down. Okay. One more thing I forgot to do is in my levels, we have our upper level over there. And now I will set my profile depth at 0.3. Okay, now let's run our simulation. Use solid verify. And as you know, it'll go down. It'll create the chamfer and let it now run till the very end. But note what happens over here. It worked exactly on the geometry I chose, but it also ate away at the corner over here. And that's actually completely, it's exactly what I asked it to do. The tool worked exactly on here. Because the diameter, however, is larger than the cutting diameter that I'm using, it actually gouges into the part over there. The way we can deal with that without creating start points and end points over here is simply by going into our technology, and in our modified geometry, we can go to start and end extension. And in this particular case, I'll just write a value of -3 millimeters. The same thing with my end as well. Let's take a look at the top view. You can see this actually happening as I'm creating it. You can see the end will also be -3 millimeters. And since I want this on all of them, I'm going to click apply to all. And then all of them will be updated as well. So instead of creating points for sketches from point to point, I can do it this way a lot quicker. Now this time when I do my simulation, I'll do it actually using Solid Verify. What you'll see is very simple. The tool this time goes down and only machines where it needs to machine. As you can see, this time it did not gouge into the wall over there. Rather, it went down with that 3 millimeters offset to the point. Let's take a top view of the simulation itself. Now zoom in over here. You can actually see, actually let me do this using HostCAD. You can see it a little better. You'll see that the tool goes down. And you'll note, let me zoom in over here, it's not touching that wall over there. It's actually staying that much away, going across and going out, doing the maximum that you want to do, that you can do on this part with this kind of a tool. So what we actually saw over here was being able to use modified geometry also, in order to do closed corners such as this one by just giving it a negative offset extension. Okay, just to review what we've actually done here in the entire webinar is, first of all, we've seen how to use templates, how to create templates, how to put them as default templates as well, and how to actually choose different defaults if you want to do that. In other words, working with templates. We also saw working with group templates, how we can do that as well. And of course, we also showed how we can use modify instead of having to create sketches to help us create the geometries we wanted. Okay, that's basically it for today. If there are any questions, I'll be willing to answer any questions now. Again, this webinar is being recorded and will be made available on our site. So you should be able to see it there on our site as well tomorrow. All webinars, if you want to actually see them on our site, all you have to do is go into our site of solidcam.com, as shown over here, and go into our webinars, webinar recordings, and you can see the webinars over here. We have our latest webinars and a list of all different types of webinars we have over here. For instance, this was last week's webinar. You can see that over here as well. And you can even download the video if you want, and you can even download the parts if you want. Okay, I'd like to again thank everyone for joining us on the webinar. Have a great weekend, and see you in our next webinar. Take care, and bye-bye, everyone.